Hi. That was perfectly timed, you guys. That was good. Yeah, perfect. Hi. Welcome. Welcome back. So the last couple days that we've been working together, we started on exponential functions, and we looked at how you evaluate those. We talked about the graphs, what they looked like, growth and decay. And yesterday, we gave you a spoiler alert because we started talking about the asymptote. Today, we're going to continue using the asymptote and the equations in order to graph these. Yesterday, the graphing was done with, hi, here's some values of x. Evaluate it, create yourself a bunch of points and tables, plot those points, connect them, you have your picture. Today, you're doing the same sort of thing, but this time, I'm not giving you values of x. You have to create them on your own. And so I'm going to show you the shortcut and the trick that I used when I was creating those x values for you on your assignment yesterday, to give you the power so that you can select values of x and you can do it with confidence knowing you've selected some really good choices. Okay? Before we get started on that, though, I want to introduce you to the general form of exponential functions. Doesn't this thing look familiar? Yeah, right? So from all of the other function types that we've looked at, what did that thing do? Stretch, compress, reflect. Were these horizontal or vertical? Vertical. These were vertical stretches and vertical compresses, and vertical reflections, meaning they flipped across the x-axis. Lovely job. Doesn't this thing look familiar? What did this thing control? A shift. Which direction? Horizontal, left or right. And this thing? Yeah, some sort of vertical shift, some sort of up or down craziness. Beautiful. When we were first talking about all of those transformations, I was using the letter B smacked right up against the x, multiplying to x, to represent the horizontal stretch and compress and reflect. Notice how we're using the B now, not for those horizontal ones, but for the base, which means the coefficient on x, just hand her the box. The coefficient on x, the number you're multiplying to x, is still going to be the horizontal stretch or compress or reflect. But I'm not going to write that in the general form because that's way too many letter B's. And I'm sorry, I don't like that many B's in my life. I'm so glad you caught that joke. I said it, I was worried it wasn't going to work. In order to graph these by hand, and I do want you to learn how to graph them by hand because we are very, very reliant on our technology, and we just mindlessly put them in there and we go, oh, there's the picture, and we trust it. And the problem with that is that you could have typed it in incorrectly. It's possible, right? Instead of pushing the 7, you pushed the 4 on accident, and you didn't notice, and you hit enter, and it spat out a graph at you. And if you just copy it and take it for granted, you could have had a typo and you could have gotten it incorrect. Whereas if you learn how to read all these symbols, graph it by hand, and see what changes in those numbers cause changes in your picture, you know before you even type enter, más o menos what this thing should look like. So that way when this thing spits out a picture of a rocket ship instead of a swoopy thing, you know you probably typoed. Okay, let's fix it because we don't want pictures of rocket ships. We want pictures of the swoopy thing. Okay? All right. 2 things let you graph this by hand fairly quickly with the least amount of work. The first thing is a typo. Please fix my typo. The word asymptote has a P in it. You will never hear this when it goes to the bathroom because the P is silent. But it's there, I promise. So you need to know where the horizontal asymptote is. And I hope that you're sitting there going, she's being very specific with that today, isn't she? I'm saying it's a horizontal asymptote. There's a possibility for the horizontal asymptote. Then there's a possibility for what other kind of asymptote?
Vertical.
Yeah, vertical one. Yeah, he motioned it at me and you all said the word. It was perfect. This type of graph doesn't have vertical asymptotes. As you've seen, the domain is all real numbers, which means we're not excluding. We don't have a wall like this for it to swoop this way. Okay, we've got a horizontal one, so the graph goes and levels out. Okay, but we are going to study a graph that has a vertical asymptote. So I'm glad it's in the back of your head of this can exist. To find the horizontal asymptote, and here is your more formal definition of it. In order to write that, you're going to find the value of k, because the equation can be written as y equals k. We're going to show the asymptote with a dashed line, because in dashed lines in graph world represent ain't nothing there. Full colored in line means I got something. But since the asymptote is the line that the thing doesn't reach, we're never going to actually have values at the asymptote. So we're going to make it a dashed line so I can see it, but I'm representing it as ain't nothing there. Okay? On this one, let us find the horizontal asymptote with its silent p. What is the horizontal asymptote of this first example? -2. Can you give me the entire equation for the horizontal asymptote? Beautiful. Y equals -2 is what she said. And she grabbed that -2 by looking at the number in the k position, with k coming from our general form. So whatever number is in that position, that's your asymptote. Don't think too hard about it. Just grab it and go. Are you guys tired of writing the word horizontal asymptote? Yeah, I've only written it like once, and I'm already like, yeah, no, I'm good. I don't want to write it again. Let's give you a shortcut to write it, okay? Ha, yeah. Ha. H-A. But make that A not big like the H. Make it a subscript, almost like when you were in geometry and you were writing like x1, y1, x2, y2. And those 1s and 2s were small. Because we were using it to count. I have one x and I have a second x. Well, this I'm using it to represent the fact that that H is not the same as this H. It doesn't mean horizontal shift. That H is standing for the asymptote. Okay? So that's what that little subscript is telling us to do. All right, give me the equation for the horizontal asymptote of g of x. Y equals 4. I love it how you didn't wait for me to finish. No, seriously, I did. That made me happy. I wasn't being sarcastic. I love that you just look. I know it. It's good. So good. All right. So first things first, find the horizontal asymptote. Boom, done. The second thing you need to do, look at this one, is look at the equation and find the exponent. Okay? Find the exponent and then figure out what value of x makes the exponent 0. Set the exponent to 0. Solve that thing for x, and whatever value you get for x, start by plotting that point. Evaluate that one, because it's going to be an easy number to deal with. Because when exponents are 0, the thing turns into a 1. Motioning silently works. Okay? All right. Let's practice this technique here, start to finish. Okay? So we're going to start off by looking at this and finding the horizontal asymptote.
Y equals.
Oh, I thought you were.
I was waiting for y'all to answer
Oh.
so that I could copy your work, because you're brilliant. This one's on the homework? Oh, nice. I didn't realize that this number was on the homework.
Which one?
I don't know.
The first one.
The very first one. It is.
Wait.
Okay, right on. Very good. Go me with copy and paste and not changing numbers. Okay. Yes, very good. So, if you want, instead of, well, I'd like you to do this on your notes, and then you can just transfer it later. Okay. I'm going to color this thing in blue. All right, so now that I know where my horizontal asymptote is, I'm going to go ahead and graph it because that's the easy one. And if this were a partial credit question, I would get 1 point for drawing the asymptote. So I'm going to go to y is negative 2, 1, 2. And I'm going to make a dotted line all the way across my graph at the horizontal line.
Wait, miss, it's a little blurry.
Oh, it is? Oh, it is. Look at that. Thank you so much. I'm still waiting for one of you to, instead of going, it's blurry, for one of you to pop off and go, Miss Focus! And now that I've said that, I've just opened myself up for it. Okay. Horizontal asymptote is in place. The next thing that I need to do, it says find value of n in 4 points. What we really mean is, what value of x makes my exponent, did I spell that right? Yes. Makes it equal 0. Here's my exponent. And so I'm going to write exponent equals 0. All right, solve it for x.
X equals negative 5.
Subtract 5 from each side and you get x equals negative 5. I'm going to then use this value right here, trying to find a good highlighter that I want to use. I guess I'll use this one. Okay, I'm going to grab that value and I'm going to plug it into my function right here. And I'm going to evaluate that. But remember, that value made the exponent 0, yes? Yes, because that was the value I calculated, setting the exponent to 0. I know, without having to do any work, that this up here is 0. I'm going to ask you to let your brains hurt for just a second. This right here, I need you to realize that I don't have any parentheses, okay? And so when I don't have parentheses, I cannot think of this as negative 4 to the 0 power, but rather as negative 4 to the 0 power, okay? Listen to the words again, because I know, it's like, what? You just said the same thing. Listen to the pause, because the pause are where the parentheses are happening, okay? This is not negative 4 to the 0 power. It's negative 4 to the 0 power. Okay? Listen again. It's not negative 4 to the 0 power. It's negative 4 to the 0 power. That power is happening on the 4, and then the negative is getting applied to it. Okay? Yes? Okay? Okay. I know that if you were like, Okay. So I've got the negative hanging out, and then this is going to be my 4 to the 0 power. 4 to the 0 power is? 1, because anything to the 0 power is 1. 4 to the 0 power is 1. 400 to the 0 power is 1. Elephant to the 0 power is, look, I don't care what I give you. If I put it to a 0 power, you're just going to say 1. Negative 3. Okay, so I'm going to go back to my graph and I'm going to plot that point. X negative 5, y negative 3. So I'm going to plot the point. I know you can't see it, but I'm over here on my graph and I'm plotting negative 5, negative 3. Do that on your graph. I'm going to scoot this over. There's my point at negative 5, negative 3. All right. The asymptote is a wall. Thanks, Trump. that point, that graph, cannot cross the wall. So he hopes.
No matter how many goals they
Which means if this graph goes in the up direction, it's going to bend before hitting the wall. Okay? So it's either going to do this and swoop toward the point from the left this way, or it's going to swoop away from the point going to the right. And I don't know which way it's going to go yet. And so from here, if I pick one point on either side of this x equals minus 5, then it'll tell me which way that swoop is happening. Okay? So I'm going to calculate both of those points just to see where it's going. Okay? So I'm going to grab -6 and -4. So we're going to go -6 and we're going to go -4. Okay. And again, there's no parentheses around this base, which means that negative is not part of the base. That negative is sitting in the A position, hanging out. If I'd put it in parentheses, then it would be part of that base, okay? Okay. Yesterday's discussion, we talked about how to handle negative exponents, and we got rid of those negative exponents by turning the base into reciprocals. So the reciprocal of 4 is 1/4. And then I apply the power again, but this time I make that power positive because I've taken the reciprocal. That's the Reciprocal Law of Exponents, I think is the name of that law. Okay. So I've got a fraction. I've got -4 minus 2. Okay. So if I go to -2, and then I'm going to go down just a little bit more, I've got a fraction. If I continue making this more and more negative, right? If I continue going this direction, this is right about there. Sorry, I got something in my mouth. Felt weird. Okay, that's about where that point is. That's about 2 1/4. Okay. If I move this way, my graph isn't going to suddenly bounce and, go really far down. It's going to get even closer to the asymptote. Do you notice? So that tells me already that this graph, where's my pen? There's my pen. This graph is going this way. Okay. Yeah. All right. So now let's look at what happens when x is -4, and I'm going to go ahead and add x is -3 also, because I have quite a long graph here, and I want to see where it's going to go so I can try to fill the graph paper with graph and not have just kind of this tiny little piece. Okay? So I'm going to go ahead and do 2 back to back here. I know I'm being quiet. I'm trying to think here. Again, we're thinking of that base as the +4, not as the negative number. Okay? Oh, everyone okay?
What happened?
I don't know.
Oh, my back fell.
Okay. You're okay though, right?
Yeah. I'm not paying attention.
All right, now I'm going to plot these points. When x is -4, we're going to have, oh gosh, that's not a 6, that's a 2. We're going to have a -6. I had already did it in my head and I wrote it. And then when x is -3, we're going to have out a -18. And I'm going to plot both of those points on here, and I'm going to see that that thing is swooping way down really fast. Okay, those numbers are growing more and more negative really quickly. Okay? Here I go. I'm gonna zoom out a little bit so I have room for my hand and things. Okay, -2 is at -6. Okay, so 2, 4, 6, 6, 8, 10, 12, 14, 16, 18. Okay. And there it is. There is my graph of f of x equals -4 to the x plus 5 minus 2.
Did you say that it was 18?
Yes, ma'am.
Oh.
Questions on this before I move forward? Okay, good. So now,
-3, -18.
yeah, -3, -18, yes, sir. Over here on this side of the room, questions? No, 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 no. In the back? No, we're good. Here in the center? Front and center? Doing good? And then on this side, on my wings? You're happy? Okay, good. What's the domain of this thing? Yeah, all real numbers. We're eventually going to get to all of the x values. It's just going to take us a little while in one case. Look, in my day, the hashtag symbol meant numbers, okay? So I'm bringing it back. That does not say all real hashtags. This is all real numbers. All real hashtags, that would be weird. All right, what's the range?
Is it all numbers?
It's not because we have that asymptote.
Y
Less
is
than.
greater than, no,
That's less than.
less
Less than
than negative 2.
Yes. Yeah, because that asymptote is a wall. We're approaching it, but we're never going to get it. And so we're never going to be equal to -2. We're never going to be able to cross it, so we can't get above -2. And so we have to stay less than it always. Good job. So for the
Okay.
range on these, I'm sorry?
That's
Haven't gotten there yet. The range on this, it's as easy as grab the asymptote. Look at the asymptote equation. Yeah, just grab that equation, change the sign. If it's above the asymptote, it's going to be greater. If it's below the asymptote, it's going to be less than. Easy done. Crumple, crumple, crumple. All right, let's classify this thing. Growth or decay?
decay.
Decay,
You know, and I agree with why you're saying that.
because from left to right.
Because if you move left to right, which is what I said naively, when you look at the picture left to right, it's going more and more negative. The issue is that this isn't a decay. Because to decide if it's a growth or decay, you have to look at the base. And in each case, this base was greater than 1.
Okay.
And when the base is greater than 1, it's a growth. All right, I know what you're thinking right now. You're going, but miss, it's going more and more negative. That's got to be a decay.
It's growing.
It's growing more. Huh? How is it greater than 1? Because I pulled that negative away from the 4. I didn't think of this as -4 to the 0. -4. I did 4 to the 1 and then shoved a negative onto it.
Wait a minute, so if it's less than 1?
If it's less than 1, between 0 and 1, that's when it's a decay. So when it's some sort of fraction that's smaller than 1, it's a decay. But when the number is bigger than 1, and again, you have to ignore the negative, unless that negative is in the parentheses, in which case it's a whole other creature. We're not talking about that one, because that's weird. Okay?
So if there's a negative like that, like it's not really.
It's not, the base isn't negative. Yeah. And that's the weird thing about these, and I get that. So you gotta force yourself to be like, nah, base ain't negative. Okay? So let's take a moment. Let's take like a moment to try to figure out why the picture, kind of looking like a decay, because it's getting, smaller and smaller as we go. More negative is smaller. why this is still considered a growth. And you had mentioned a little bit. You said, but it's growing more negative really fast. Right? Okay, so if we look at it that way, it would be a growth. But let's look at it a different way. What if I graphed it without that negative in front? Okay, I looked at this as just 4 to the some exponent. What would that thing look like?
Go up.
It'd go this way, right? Very badly drawn, but it would go that way. We opened the day talking about this and discussing that number, the symbol in that position, controlled a vertical stretch, a vertical compress, or a vertical reflection. What value caused the reflection? A negative in that position causes a reflection. And so if I take this and I were to reflect it, what would it end up looking like? That. It's a growth. Because it comes from a growth, it just got reflected. That was it? That's all I had to do. Go ahead, yeah, go ahead. You know what? I do want to applaud the light bulb moment because that's such a powerful sound. Thank you guys.